So it's Friday. Yay! Can you shut that door so we can hear? Thanks. All right. So we are on lesson 3 in unit 7. Okay. Everybody a minute to get in. What's up?
I can't see it.
You can't see it?
Yeah, I couldn't see it over there.
Why don't you join the Zoom? That might help.
I do. I just joined Zoom.
I know because of where we put chairs, it's not ideal. It's not how I would have set up my room, but hey, gotta do what you gotta do, right? Okay, so today's lesson is non-adjacent angles. Well, do we know what that means? Non-adjacent angles.
Because adjacent means two angles beside each other that are sharing a line.
Okay.
So non-adjacent would be the opposite.
Okay, so they're not going to be next to each other, right?
Or they might be next to each other, except that they don't extra.
Except the lines aren't connected.
So if their lines aren't connecting, then they're not adjacent. Okay?
Mm-hmm.
All right.
Even if we're going on paper, we have to go on the color.
Yes, please. That way I know you're working. Do you need the link? There it is. All right. So since we know what non-adjacent is, we can go on. So our learning goal is let's look at angles that are not right next to one another. By the end of today's lesson, I would just love it if you could determine if angles that are not adjacent are complementary. What does complementary mean?
Complementary means
They add up to 9.
Okay, if she's starting to talk, you don't butt in, okay? I'm not a big fan of raise your hand and wait to be called on. I don't mind if you speak out, but if somebody's already talking, don't cut them off, okay? All right, so complementary are they total 90? Supplementary are
total of 180.
total of 180, okay? Vertical angles. Anybody got a clue? That's what we're gonna learn today.
I remember yesterday.
You remember what I think we did say yesterday what they
Yeah.
were, didn't we?
Yeah, I thought.
You remember the word, but you don't remember what they are.
Yeah.
Vertical angles are like V-shaped.
Uh-huh.
They're across from each other.
They're across from each other when two lines intersect. Good job. All right, so we're gonna start out with a warm-up called Finding Related Statements. If we know for sure that A plus B equals 180, what are some possible values for A and B?
90 and
No, type it in, A equals B equals. Or write it in. I think I made it a drawing slide, not a typing slide. Okay. All right, I got a 90 and a 90. Can we be more creative than that? Do they both have to be positive?
Yeah.
All I said was A plus B equals
180.
180. So do they have to be positive?
No.
Nope. Okay. Do they have to be whole numbers? No.
They just have to equal 180, no matter what.
Yep, you add them together and you're gonna get 180. Okay. There we go. I'm seeing some different ones now. 200 plus negative 20. Awesome. What if A equaled 180? What would B equal?
0.
0. Uh-huh. All right, so we could go on all day coming up with these, couldn't we?
Mhm.
Because there is an infinite number of them. Okay, so I trust everybody has at least one pair. Matthew's finishing up there. Oh, I like it. 37 minus negative 143. Awesome. Okay, now the next thing is, in this activity, we know for sure that A plus B equals 180, but we don't know the exact values of A and B. So, given A and B are numbers, and A plus B equals 180, which statements also must be true? Circle them. Which statements must also be true? Circle something, Jeremiah. Max, same thing. Josiah, see what you got for me. If you're doing it on paper, that's fine. Just put a check mark on the screen and I know you've got something written down. Okay? But these are kind of like your notes, so they will come to you in an email. All right, let's see how we did. All right. A is always true. The first one is always true. Why?
Because 180, A and B are the sum of 180.
Mhm.
So you would have to do 180 minus
Right.
B.
Could I also say 180 minus A equals B?
Yes.
Okay, that's kind of like that math facts thing you learned back in elementary school. Okay. All right. Why is the second one sometimes true?
Oh, because A is being subtracted by 180 instead of subtracting from 180.
But can A and B still equal, A plus B still equal
Depends.
180? So what are we going to end up with? Is A going to be, one of them's going to be positive and one of them's going to be negative, okay? Okay, why is C, the third one, always true?
Because A plus B, that's basically saying 1A plus 1B is 180, and if you're 180 times 2 is 360, so 2A plus 2B.
Good, if we factored out the 2, that would give us 2 times A plus B with A plus B in parentheses, right? So if I multiply that side by 2 and that side by 2, would it be that? Yes, okay? Why is the last one sometimes true? Liam?
Because if you,
Oh, go ahead.
never mind.
Never mind. Okay, Liam, why is the last one sometimes true? Any idea? Makata?
The reason why the last one is sometimes true is because that can be both A and B, but it's not always A and B.
Because A could also be 0 and B could be 180. We thought of all those possibilities in the previous
A and B
thing.
don't always equal 90.
Yep.
A could sit here and be, let's say, 260, and B could be negative 80.
Yep. Okay, so that's why it's sometimes true.
I'm a little bit confused because it's saying that A is 90, like it's asking which one's true.
Well, what does it say? Actually, they asked you which statements must be true. So which ones must be true? This one is always true. This one is always true. This one is true in some cases. This one is true in some cases. Okay? Because A doesn't always have to be 90. A can be any number, and then B will be whatever it needs to be to make it 180. Okay? Does that make sense? A little bit more? All right. Any other questions? All right, there is a reason for all that thinking. All right, you need your toolkits now, so go ahead and get those out. If you printed this out, it's probably, you want to get it out now. This is activity 2 from the activity PDF. So what I want you to do is I want you to spend 2 minutes using any of your tools in your toolkit to identify any pair of angles in these figures that are complementary or supplementary. So let's start with supplementary. Find me a pair of supplementary angles. Go. That's all I want to know right now is a pair of supplementary angles. So think about what tool are you going to use to figure that out? Yeah.
I didn't bring mine, I don't think.
You're supposed to leave it in your backpack, so you always have it. There you go, grab one. Do we know how to use a protractor?
I don't remember.
You don't remember. Who does not remember how to use a protractor? Be honest. Okay. So you didn't watch the video, so let's go back and do that one. Let's see if I can get it to work. It worked last core. Didn't work first core, but it worked last core. All right. Full. And that's where it goes wrong. Play.
Measuring angles.
All right, as soon as I make it large, it's not going to work. So we're going to keep it small, okay? Can you see it well enough? Now it's not going to work. Okay.
Play song from the beginning again. And plus,
There it goes, it's loading. You gotta love it, right? All right, we'll try it this way. It's a really cool video. Especially since
it's working.
Is it working now? Why do I hear nothing?
It's not working anymore.
We use a protractor to find the measurement of any angle. Line up the vertex of the angle at the center point of the protractor. Make sure the bottom ray of the angle goes through the 0.
Never mind, let's try that again, Miss Blair. Okay, so you're going to have a point. So in this picture, back to the picture, you've got point A, D, C, and B. So put your protractor, the center of your protractor, on the dot. So for my center, it would be the center of the protractor, and then you're looking for the straight line across, okay?
Measuring angles. We use a protractor to find the measurement of any angle. Line up the vertex of the angle at the center point of the protractor.
So see here,
Make sure the bottom ray of the angle goes through the 0.
right here on the 0. So you
Count up from 0 until the other ray intersects. This is the measurement of your angle. This angle has a measurement of 60 degrees. Keep in mind, make sure you always count up starting from 0. If you started from 180 degrees, you would get the wrong answer of 120 degrees. Let's try another example. Line up the vertex of the angle at the center point of the protractor.
Right here. Put the 0.
Make sure the bottom right of the angle goes through the 0. If the rays are too short, you can always extend them.
So this one is,
Count up from 0 until the other ray intersects. This is the measurement of your angle. This angle has a measurement of 137 degrees. Keep in mind, make sure you always count up starting from 0. If you started from 180 degrees, you would get the wrong answer of 43 degrees.
okay, but could you look at that and say it was
Drawing
obtuse?
angles. We can also use a protractor to draw an angle.
Okay, we'll do that when we get to triangles. All right, so did that help you learn how to use a protractor? All right, so what I want you to do is I want you to measure angle A, angle D, angle C, and angle B. Go ahead and measure it. Measure those 4 angles inside the quadrilateral.
Which 4 angles?
What?
Which 4 angles then?
A, B, C, and D. You see them on your paper? No?
I said yeah.
Okay.
I found the complementary and supplementary.
All right. You're ahead of the game. Using my pencil. All right. Anybody need more time? Okay, I'll wait. All right, what do we get for angle A?
Angle A would be 55.
55, do you agree with her? Did somebody get something different?
Yeah.
What'd you get?
I got 55.
Then why did you say you disagreed with? Okay. You got 55 as well? I got more like 59.
Miss Laird,
Yeah,
so we go by the bottom numbers, not the top, right?
you're always starting at 0. So when I put my protractor on here for angle A, I'm going to put my protractor right here. This is my 0 right here. So I'm counting up from 0. Thank you. Okay? If you count the wrong way and you get the bigger number, is this an acute angle or an obtuse angle? Acute. So you know it's going to be less than 90 degrees. The other number there is the obtuse angle that goes opposite out of it. So it's no big deal if you don't count to 0, it's just easier. So you're gonna put this here, the center of it, you're gonna line this up, and then I'm gonna start with 0 down here. And if you've got anything between 55 and 60, you're pretty good, okay? It can be the what?
I got 58.
That's good. Okay, anything between 55 and 60. And that could be the difference of the copy machine. Okay? All right, so if this is, what do we want to call it? 58, since it's kind of in the middle. Okay, if that's 58, what did you measure D to be?
120.
All right, you got 120, but you had 60 right here, right? What did you have there?
55.
55? Go back and measure
This
the,
angle A.
what would angle D or B be? D or B be?
D or B?
D or B?
B, I got 125.
All right, so you had 55 here, which, did you get 55 for C as well?
No, I got 57.
You should have gotten 55 if you got 55 here. It's a difference in the copy machine, okay? All right, and then here, you got what?
I got 125.
Yeah, that's what I got.
Okay,
And I did
okay, now, what does supplementary mean?
It's 180.
Some 180s. So give me a pair of supplementary angles.
A and B.
Angle A and B.
And then C.
Somebody over here, give me supplementary, another pair. Somebody on Zoom, give me another pair of supplementary.
D, C.
D and C,
What does supplementary mean again?
straight
That
line,
adds up to more than 180. That adds up to 180.
adds up to 180,
D and A and then B.
okay? All right, now, are there complementary angles in the quadrilateral?
No,
No, okay?
unless we're adding up 3.
No, we're not at it, you can't even do that with 3.
Yeah.
Okay? All right, so we're gonna look for the triangle. Are there supplementary angles in a triangle?
Yes.
There are? What does supplementary mean?
Supplementary means
Equals to 180.
How many angles equal 180?
2.
2. Are there 2 angles there that could equal 180?
So
How many degrees are inside a triangle altogether?
3 or
Well, think about it. An equilateral triangle has, do you know how many degrees each of the angles are in an equilateral triangle?
Equilateral triangle. Yeah.
All equal.
All right, measure it. Go for it. Measure the angles in there and let's see what you get. Okay. What was the angle E?
90.
That was a right angle, right? Okay. Angle F, I got 20. Did you get something close
I
to
got
20?
25.
I got 21.
I
Try,
got 21.
try that again, Jahan.
25.
21. How?
Be careful, you're starting at 0. I don't see how you could get 25. Do you have your protractor where your line is on top of this line? Okay, if your line is down below it, you're not measuring the angle itself. Okay,
And then
you should
for-
get something around 20, and then you should get something around 70 up there,
I got 69 from June.
okay?
Wait, how?
So how many degrees are inside of a triangle?
Oh, oops, never mind.
180,
I kept thinking, I was looking at the wrong one.
Okay.
Yeah, I was gonna,
okay? So can there be supplementary angles inside a triangle?
No.
No. Can there be complementary angles?
definitely.
Definitely if we have a right triangle, okay? If you have a right triangle, the other two have to be complementary. So angle G and angle F are complementary. Okay? All right, so the next question I have for you come on, go to the next slide already. There we go. How did you identify complementary and supplementary angles? So tell me what you did. What tool did you use? Write down what tool you used. Write down what you know about complementary and what you know about supplementary. Okay, I measured with a protractor. We found the angles with a protractor, So what were you looking for when you were looking for supplementary angles? Whoa, supplementary angles sum of 90 or supplementary a sum of 180?
180.
180.
I was thinking that.
Supplementary is a sum of 180. Okay? We're going to keep writing this over and over again until you get it in your head. Jahan, supplementary angles do not equal 90, they equal... Oh, I see it, okay, protractor, complementary is two angles that equal to 90, okay, gotcha. Commas would be helpful in that. Okay. I won't count off for spelling, don't worry about that. Supplementary.
Supplementary.
Okay. Matthew and Matthew, are you there?
Yes, ma'am.
Okay. Are you doing it on paper or are you not on the slide? You're not typing on my slide deck? All right, who needs more time? Don't see anybody typing, so we must be good to move on. All right, now we're going to talk about vertical angles. Read the task to yourself. Go ahead and read it to yourself. Just the top paragraph up there. Well, actually the two paragraphs. Now read it again and underline any words that you don't understand, that you don't know. Underline what you don't know. All right. Straight edge, we don't know what that means, okay. Conjecture, okay. Jahan's drawing for me already.
I was drawn with a straight edge.
Cool. All right. So that looks like the two were, so we all know what intersect means then, huh? Okay,
I know what it is.
okay. All right, so we don't know what a straight edge is. If you look at your protractor, this is a straight edge. If you look at your compass, if you have one of my compasses,
This
it's
one.
got a straight edge on it. A ruler is a straight edge. It's something that allows you to draw a straight line. All right? Because by hand, we probably wouldn't draw a really good straight line. At least I don't. Okay? Conjecture. That's a science word. When you do an experiment, you make a prediction. So you make a conjecture, a statement we think is true, but we aren't certain. Okay? So let's go back to our task. Use a straight edge to draw two intersecting lines. So you've got paper. You can use the back side of it, or you can draw it right here on the side. Use a straight edge to draw two intersecting lines. Use a protractor to measure all four angles whose vertex is located at the intersection.
I mean,
Okay?
so I already did it.
Well, that's, yeah. Okay? Remember to draw arcs to label the degree measures of your angles. So if you've got two angles that are the same, you're going to give them the same number of arcs. Okay, do you understand what I mean by that? All right, I'll show you that in a minute. So just go ahead and measure all the angles. Put the measurement in there. Once you're done, draw another, if you're already finished, draw another pair or another set, but don't do the same cross as you did before, and measure those angles. Anybody need help? I'll be happy to help if you need help. Measure your angles as accurately as you can. What were yours? Just draw another straight, okay? So what was the angle measurement here? This is where you measure your angle. You write your angle measurement in the middle of the angle. So you're gonna write your angle measurement right here. Okay? It's that 50 degrees here. Okay, anybody need more time? Have you measured all four of your angles?
Yeah.
All right,
Yeah.
Type in what are your conjectures.
Gotta get.
Type it in. I know I don't want to forward it because I'll lose those angles. So go ahead and type it in on your Pear Deck. I changed it on your Pear Deck. So you're typing on your Pear Deck right now. What are your conjectures about what you notice? What do you notice in your angles? What do you notice in my angles? What do you notice? I see we've got some numbers there. What are you noticing about your numbers? What are you noticing about my numbers? Yeah, they're probably different than mine, but what do you notice about the numbers? There's some kind of pattern there. Do you see a pattern? Okay, somebody said none of mine are even. I'm assuming you're saying like mine are 45, 45, 135, and 135. Why do you think that's true? Are we accurate measurers?
Yeah.
Is it difficult to get a real accurate measurement using our tools that we have? Yes, because doesn't the width of the line figure into that as well?
Yeah.
Okay. But are they close to each other?
Yes.
Okay. Does anybody notice anything else? Do you notice anything about the adjacent angles?
Yeah.
Okay, type that in your conjecture.
I did.
I noticed the adjacent angles. None of them are equal, okay? So looking at mine, what can you tell me about my adjacent angles?
They're even, or they are what is the word? Congruent?
If you add at least two of them, one end should be the same as the other.
What do I mean by adjacent?
The two angles that are connected.
Okay, so these two are adjacent, right?
Yes.
What can you tell me about those two angles?
They will both add up to 180.
So they are called
So they are called
Supplement.
supplementary. What can you tell me about these two angles? Are they adjacent?
They're,
Yeah.
they're supplementary.
They're supplementary. What can you tell me about these two angles?
They're supplementary.
Are they supplementary? What do you-
Yes.
and these two?
They're supplementary.
Okay, so adjacent angles are all supplementary. Okay, what can you tell me about the angles that are across from each other?
the angles that are across from each
They're
other will be the
complementary.
same.
Should be the same.
They should be the same. They should be congruent.
They are
And they are,
also supplementary. I mean, complementary.
no, they're not.
Oh, not those. 45 plus 45.
This one,
Yeah. I was
this
talking
one
about
is,
those.
but this one's not.
Yeah.
Okay, that one just happens to be complementary. All right? Okay? Just like that one happens to be supplementary when they're vertical. All right, so a pair of angles formed by two intersecting lines that are opposite each other are congruent, and they are called vertical angles. So angle A is vertical to angle B. Notice with the arc, they have a tick mark, one tick mark. That means that that is congruent, okay? Angle D and angle C are congruent, and they are vertical angles. So you end up with two pairs of vertical angles when you take two straight lines and intersect them. Okay, and this will be true every time. A and D are going to be supplementary every time. C and B will be supplementary every time. D and B are supplementary. A and C are,
Supplementary.
A and B are
Supplementary. No.
Complement.
vertical, and they are congruent. D and C are
Vertical.
vertical, and they are
Congruent.
congruent. If you think about, they make the V, that makes them vertical. Okay? When they come in at each other, you got V's facing each other. Those two angles are vertical. Okay? All right. So now what I want you to do is identify 4 pairs of vertical angles. And you can do that by using color if you want to. So like I would come in here and I'd say, okay, here's one angle. What is vertical to that? Which angle is vertical to that?
Which angle is,
Okay, so if I was to draw this angle right here, what's vertical to that?
E.
And they're all angle E in the middle there.
Oh, wait.
AED.
AED, okay? And I would put 1 tick mark in it. Okay, can you find another pair of vertical angles?
B,
Can we print this
D,
out?
B,
Is it on paper?
AEC.
Yes, no, this one is not on paper. This was the next page, and I only told you to print out the first page.
DEB and AEC.
Okay, so make those 2 different colors. And they are congruent, so we're gonna put 2 tick marks in it. All right, how about in the other one?
GJI and HJF.
Okay, so we can do this is congruent to this. Another way that they notate it is they will just do one line like this. If we have 2 angles that are congruent, where's the other vertical angles here? What is vertical to this angle?
AJG. Oh yeah.
What is vertical to this angle?
What is vertical to IJF, which would be HJG?
There you
Yeah,
go.
that's
Is
what
that
I
what you
said.
said? Okay.
That's what I said.
Okay, and I put 2 lines there. You can notate it that way, or you can notate it with the tick marks. Okay? Questions on that? If I told you the measurement of this angle, and I told you the measurement of this angle, could you find the measurement of that angle?
Yes.
What can you tell me about these 2 big angles here?
They're
Oh, wait.
congruent.
They're
They're the same.
congruent, so I could say this plus X is going to equal that, right? Okay, all right.
Or that minus X.
Uh-huh. All right, now we're gonna do gizmos, and I'm actually gonna do it on the screen so you can watch it. Because we had difficulty in the other class trying to do it, because some of you aren't signed in. All right, so we're gonna start out with complementary angles that are not adjacent. What do we know about complementary angles?
They
Complementary
actually
angles.
sum of 90.
90, okay? So I'm telling you this angle is 34. This angle over here is complementary to both of these, because these are just same angle, but they are rotated differently, okay? So, how could let's see what that one measures. So if you go to the gizmos, I have assigned it to you. You can find it in your gizmo, and you can play with this later. So I clicked on angle measure, that's 56. What makes it complementary? Why is that complementary to this?
What makes it complementary?
What is 56 plus 34?
That's 90.
90. What if I change this angle to that? Well, now this is 74, and what's this?
16 will be way
16,
more.
is that still 90?
Yes.
Okay, what if I change, guess it will only let me change this one. If I change it here, I now have 44 here and 46 there. Are they complementary?
Yes.
Okay, do they have to be next to each other?
No.
No, if I wanted to do adjacent angles, I could do this. So I can play with, there's my two 40-degree angles, and then if I want to measure this other one, come in here, put these on top of that, and that angle right there is 50 degrees. If I change, if I rotate this, I've got 71 here. What's complementary to it? The 19, the little one right here. Or if this one is 71, this one is complementary to it there. Okay?
Okay.
All right. Then we talked about supplementary.
Miss Slade,
Yeah.
just to be correct, this isn't practice problem.
Nope, we're not doing practice problems. You're gonna do those by yourself. All right, so if this one is 141, what do you reckon that one's gonna be? If they're supplementary, what's that one gonna be?
That one would be
39, right?
yeah.
Okay, if I adjust this, do they always total 180?
Yes.
Okay, does it matter that they aren't next to each other?
No.
Nope, because I can also put them next to each other. And if I move these around, are we still gonna end up with 180?
Yeah.
Yes, okay. So let's look at vertical angles now. So what do you notice?
Line.
What do you notice about the vertical angles?
They are congruent.
They are congruent. This is congruent to this. This is congruent to this. If I move this, do I still have the same relationship?
Yes.
Are
and
they
then also-
still congruent to the one that's opposite of it?
Yes. And
Yes.
they also equal 180.
What equals 180? The vertical angle or the adjacent angle?
The vertical angles.
Nope, the vertical angle,
Oh, yeah.
the vertical angles are
I meant the
congruent.
adjacent.
The adjacent angles are going to be supplementary. All right? If you want to play around with this, it's on Gizmos and it should show up on yours. Okay. Do supplementary or complementary angles need to be next to one another?
No.
Okay, put it in the chat. I mean, on the Pear Deck. Wrong one. There we go. Okay, type it in there. Okay, I've got a no, I've got a yes. I've got a no. I've got a no. Okay, well, let's go back and look at this. Those of you that said yes. Complementary. Okay, there they are next to each other. Here they are non-adjacent. Are they still complementary to each other?
Yeah.
Yes. Same thing with supplementary. Do they have to be next to each other? There they are, but here they aren't. Okay? So no, they do not have to be. So the answer to that is no. Okay, what are vertical angles? Type it in. In your words, give me a definition of vertical angles. Remember, that was one of our goals. Okay. I'm seeing angles that are across from each other that have the same vertex. I'm seeing when we have two straight lines that intersect, the angles across from each other are vertical, okay? Not all angles that are equal to each other are vertical, okay? So the statement angles that equal the same thing is not true for what a vertical angle is. Because I could make two adjacent angles equal to each other and they wouldn't be vertical. Okay, good. All right, anybody need more time? You're gonna get the slide deck, so you will get these definitions as well. A pair of angles across from one another where two lines cross. Okay? All right, what is true about the measures of vertical angles? What is true about the measures of vertical angles? Oh, I love the vocabulary. Good. We've got some math vocabulary in here. Good job. I only got 8 people responding. What is true about the measures of the vertical angles? Kana vertical angles do not equal 180. If I go back and look at this, do my vertical angles equal 180?
Oh, vertical.
Okay, do these vertical angles equal 180? The adjacent angles equal 180 when you've got two lines intersecting. But the vertical angles always equal what?
I got confused.
That's okay, that's why we're here, so fix it. Okay, good. Vertical angles always have the same measure. And y'all use the proper term, they are congruent. Good. All right, I found this online. I thought it was kind of, well, let me get back to it. Thought this was kind of interesting, something to summarize a little bit with. Supplementary angles, do they have to be adjacent though? No, we discovered today they don't have to be, but they add up to 180. Okay, these are supplementary. These are complementary, two angles that equal 90. These are adjacent angles, okay? These are vertical angles and they are congruent, okay? All right, let's see if we can do everything that it said we should be able to do. Can you determine if angles that are not adjacent are complementary or supplementary?
Yes,
What did we do to figure that out?
we use math.
Just guess now.
We measured the angles.
We measured the angles. We used a protractor, didn't we? Or we used the gizmos where it measured it for us, okay? Can you explain what vertical angles are in your own words?
Yes.
You just did that, didn't you? All right, so give yourself a pat on the back. You met your goal. All right, so our next steps. You are going to complete lesson 3 practice problems. You'll upload a screenshot onto the practice slide. You can either do that on the PDF if you want to open up the Canvas app and pull up the PDF and you can write right on it. Or you can do it in your notebook and take a screenshot of it. I don't care. You have lesson 2 and 3 check-in and a reflection. And please do the lesson 4 slide deck before Monday. And then as always, see if you can get those 2 lessons passed in Imagine Math before tomorrow night at midnight. Okay, questions you have for me?
No.
Okay, those of you at home, any questions? All right,
No.
you have a great weekend. I will be on until 3:30 if you've got questions when you get into
Thanks,
this.
Larry.
Bye.
Miss Laird.
Yeah,
Miss Laird. Miss Laird.
yeah.
I had to do some stuff for my mom
Okay.
because she called on the phone.
Okay.
So I don't know what we're supposed to do.
We are doing complete lesson 3, practice problems.
Okay.
And then we're doing lesson 2 and 3, check-in and reflection. You can always go watch Mr. Morgan's video. He goes through the lesson activities, so that might be helpful if you missed a lot of the activities. Okay? And I will put
Thank you.
I will,
Yes.
peace. I will put the video on tonight, hopefully.
Right, bye.
Have a good weekend.
Whoa.